You're watching FE Exam Prep with Anthony Fasano from Pass the FE Exam. There are so many students who don't always know what civil engineering discipline to choose when in college. And then, when it becomes time for them to take their FE exams, they battle even more as they might have chosen a discipline that does not fit their interests or their personality. Therefore, we thought it would be helpful to start a series on each of the 5 civil engineering disciplines to give you a better idea of what to expect both in your studies and in your FE exam. We will discuss the roles and responsibilities of each one of these disciplines and the skills needed for each discipline to help you in making your decision process. In this first video, we'll be looking at the civil engineering discipline of Geotechnical Engineering. This video is brought to you by PPI, a leader in engineering exam prep for the FE and PE exams since 1975. PPI provides expert prep courses and study resources designed to help you pass the FE exam the first time. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. When you take a live online course, PPI guarantees you will pass, or you can take the on-demand course for free. With study guides, practice exams, and more, the PPI Learning Hub offers digital practice and review that you can take with you anywhere you have a device so that you can prepare during the times most convenient for you. Check out PPI today at ppi2pass.com to see all the options available for FE exam prep. Let's dive in. Before we get started, I just want to mention, especially for those of you who already took your FE exam or are getting close to taking the exam and are thinking of pursuing your civil PE exam next, that we did a complete series on our Pass the PE Exam YouTube channel about each of the 5 different PE civil depth exams in detail that explain the topics covered on each of the exams and what the pass rates are for each discipline, again to help you with your decision. You can check it out on our Pass the PE Exam YouTube playlist at youtube.com/@PassThePEExam, and it's called Civil Engineering Disciplines, How They Show Up in the PE Exams. Now, let's look at what geotechnical engineers do. Geotechnical engineering is a branch of civil engineering. However, it involves using scientific methods and principles to collect and interpret the physical properties of the ground. Geotechnical engineers are involved in all stages of the design of structures, from concept to construction. Their work is essential in the design and planning process as they assess the integrity of the soil, clay, silt, sand, and rock prior to construction commencing. They usually start in the office, assessing maps and contacting local authorities. This is then followed by a ground or field investigation based on the findings of their prep work and involves soil sampling to uncover any potential issues. Geotechnical engineers work within multidisciplinary teams supported by intermediate and junior engineers as well as by CAD technicians. As a senior geotechnical engineer on a hydro plant project, for example, tasks may include participating in technical reviews, including peer reviews, tailing dam inspections, dam safety reviews, and other studies related to the design and construction of mine waste facilities. Why is a geotechnical engineer so important? The role of a geotechnical engineer is important because they are responsible for evaluating ground conditions of a site prior to the build-out or construction. Ground conditions can vary greatly, even on a small site, and with added challenges such as climate change impacting the environment with droughts and floods, the role of a geotechnical engineer is becoming more and more important every day. They must determine whether the ground can withstand the added pressures or changes brought about by construction, which can ultimately avoid costly issues further into the project. The most important one is, of course, the health and safety of people on and around the site. What does it take to become a geotechnical engineer? To become a geotechnical engineer, you will need a degree in civil or geotechnical engineering. geological engineering, geoenvironmental engineering, or a related field. Depending on your level of entry, you may need experience in design work, for example, on dikes and dams. It is also beneficial to have some knowledge of slope stability, flow, and stress and strain software such as GeoStudy, FLAC, or Plaxis. As previously mentioned, geotechnical engineers work in teams, so it is essential to have good communication skills as well as team building skills to effectively work with various stakeholders, including your clients. It's also important to be innovative in this discipline, building a greener future for the growing population and factor in other major social, economic, and environmental factors that will be a catalyst for change. Geotechnical engineering is a mix of engineering and science, and geotechnical engineers may work in construction, determining again whether the land is safe to build on, or they may work with other scientists in tracking things like climate change. These engineers are very important, especially when it comes to the overall success of any project. They ensure that there is no possibility of unsafe ground being built on, preventing homes and buildings from being constructed on soil that could cause a landslide, avalanche, or other damage. A critical skill needed for this job is math, because geotechnical engineers need to analyze data and be able to study the geology of a specific area. A bachelor's degree in civil engineering or in another engineering field is required in order to be considered for this job. Most geotechnical engineers will also go beyond their degree and seek a professional engineering license. Here are a few responsibilities that you can expect to have as a geotechnical engineer. Observing and documenting field activities related to the construction process. Sampling, testing, and inspecting soils, aggregates, concrete, grout, masonry, asphalt, and structural steel placement. Performing calculations and data reduction of test results along with drafting. Using field testing equipment and documenting these readings. Reading maps, following directions, and interpreting engineering and construction plans. Interacting and communicating daily with contractors, technicians, and project managers. Testing of soils, foundations, reinforced and post-tension concrete masonry, structural steel, and asphalt pavement. Determining and/or performing appropriate laboratory tests. Attending project meetings and assisting in project resolutions. Assisting with the preparation of proposals. Assisting with scheduling, training, and oversight of field technicians. That leadership comes into play. Assisting with managing project budgets, project setup, and invoicing. There you have it. If you like what you've heard here and you can see yourself working in this specific field, then the geotechnical engineering discipline might be the right one for you. If so, check out our podcast, the Geotechnical Engineering Podcast, at engineeringmanagementinstitute.org/TGEP-podcast. I hope you found this week's video helpful. In upcoming videos, we will answer more of your FE exam questions and run through more FE practice problems. Pass the FE exam. We'll publish videos weekly, so please be sure to click that subscribe button, as you'll get expert tips and tricks, including practice problem solutions weekly, to ensure that you pass the FE exam. And please, I encourage you to ask questions in the comments below that I will read and respond to in future videos. If there's a specific topic you want me to cover, or a question you want answered, pass the FE exam, we'll have you covered. I'll see you next week on Pass the FE exam.